So I'd like to welcome everyone today to this Spectrum Scale User Group Expert Talk. Today's talk is IBM Spectrum Scale Container Native Storage Access. And this allows the deployment of Spectrum Scale using Red Hat OpenShift clusters. Can I have the next slide, please? So if you don't know about the Spectrum Scale User Group, we've been running a number of digital events over the last 18 months. All of the talks that we've been doing have been recorded and placed on the Spectrum Scale User Group website. We've also got all of the slides on there, so we encourage you to check back our previous talks and also to join the user group. So we've got a mailing list and a Slack community, and we're an open community for anybody to join. So we are an independent user group, but we do work very closely with IBM to develop our events. We're not a replacement for PMR. You know, there's a big community there to ask best practice, ask for suggestions on things, but it's never a replacement for the IBM support process. So if you've got a P1 system down, we do encourage you to raise a ticket rather than asking on the mailing list first. Next slide, please. So the user group has a presence around the world. So I'm Simon Thompson, and I chair the user group in the UK and help coordinate events. In addition to that, we've also got Christy, Bob, and Bill, who help coordinate events in the US, and Chris, who helps coordinate events in Australia. And I think there's a user group taking place in Australia in a couple of weeks. I think there might actually be an in-person event if they can actually do that down there. Next slide, please. So I mentioned we've been running a series of events on the website. This is a sort of overview of all of the talks that we've had. There's been a couple of container talks in the past. We're also planning some more events for the future, but we don't quite have dates lined up for those. But do keep an eye on the website for when we're publishing the next talk. Next slide, please. So today's speakers, we've got Laura Braverman. So Laura is a senior software engineer for IBM with 20 years experience in the storage industry. In her current role at IBM, she's a Scrum Master and developer with the IBM Spectrum Scale Container Native Storage Access team. We also have Harold Zeip, and Harold is a senior technical staff member with IBM Systems in Germany. He's the founder and technical lead of the Center of Excellence for Cloud Storage, and is part of the IBM EMEA Storage Competence Center. And I'm going to pass over to Laura, I think, to start today's talk. Oh, I should also mention that we've got a Q&A running. You can ask questions in WebEx events, and either the IBM team will answer the questions in the Q&A, or we'll put some of them to the speakers as well. So Laura, I'll pass over to you. Thanks.
Thank you, Simon. Hi, everyone. My name is Laura Braverman, and I'm going to take you through an introduction of container native storage access and where we came from, where we currently are, especially with our new release of Spectrum Scale Container Native Storage Access 5.1.1.1, very recent, and where we're going in the futures. I'd like to present a little demo of our new offering, but we'll get to the content here in a second. Little disclaimer here about we have things that change or in flux. This is what we know now, and just to put that out there, if things will change, and this is just a statement for now. My understanding is there's been some previous expert talks here with the Spectrum Scale user group related to containerization. One of them is episode 3 with Spectrum Scale strategy update and why to containerize Spectrum Scale. Episode 6 of persistent storage for Kubernetes and OpenShift environments, pertaining to how to access Spectrum Scale from your containerized applications. And episode 8, most recent, being a use case for AI workloads on NVIDIA DGX, OpenShift, and Spectrum Scale. So what we'll talk about today is what is Spectrum Scale Container Native Storage Access? Why would I want it? Our containerization journey from past, present, and future. An overview of what we currently have for our client cluster, our CNSA and CSI compatibility matrix with respect to Red Hat OpenShift, and also what levels of CNSA and CSI, and how does an operator simplify things? Why do you want this thing, and why is it so cool? As I had mentioned previously, we had a recent GA of CNSA version 5.111. And just wanted to highlight the notable changes for some users, or for the users that have already been adopting our product. This is our third release, so wanted to point those out. With 5.111, our big thing is our entry into the IBM Cloud Container Registry. So I wanted to take you guys through that today. It's a new packaging. Instead of getting something from Fix Central, you're going to be deploying in tandem with the container registry, and also by using some of our files on our public CNSA GitHub repository. So we'll walk through that. The demo I'd like to show you for you today is that process of getting the entitlement key from my IBM to access the IBM Cloud Container Registry, and then also walk through just a portion of our installation process, just to the point to show you updating your global pull secret with these credentials, and walking through pulling the actual images from the ICR so you can see your pods and container images being realized. So I'd like to take you through that. And then in closing, we'll look forward to what we're looking to develop and trying to put a call out for any kind of features that you would like to see in the future. So what is IBM Spectrum Scale Container Native Storage Access? So CNSA, as I'll abbreviate, supports the Red Hat OpenShift container platform with fully containerized deployment. So what this does is it allows you to run Spectrum Scale on Red Hat CoreOS worker nodes where you can't typically run Spectrum Scale. So Red Hat OpenShift container platform is unique. It's well suited for containers. Your master and worker nodes are running Red Hat CoreOS, which I find it lends itself very well to containers because it's almost like there's nothing. So the world is kind of your oyster because, well, I guess, because you don't have anything, you kind of have to bring your own campground with you. So, and that's kind of what we need to do with our pods and our containers. Anything that we need access to, that's what we need to bring along too. The one caveat with Spectrum Scale is we require the kernel. So we do rely on OpenShift and its machine config operator to provide us with the kernel header and devel packages to build our general purpose layer needed for Spectrum Scale. So we're a bit unique. We're a file system. So that's kind of where we are with Red Hat CoreOS and running on OpenShift. This allows you to have your containerized workloads run against OpenShift and access your backend storage in Spectrum Scale. So why would I want it? It's super cool. It brings scalability and performance of Spectrum Scale to your containerized workloads. So things that you run in your traditional environment can now be run on OpenShift. It integrates OpenShift into your data-intensive workflows. Again, you get that reliance, and that's another cool factor about OpenShift and CoreOS is just the scalability by means of the operator, and we'll get to that. You're not handcrafting every single Spectrum scaled node. You're relying on your operator to roll that out, and your admin should not be touching the worker nodes at all. So what this means is you have a consistent system or a consistent Spectrum Scale cluster throughout your OpenShift cluster as well. So the management then becomes that initial configuration, and then it should run as advertised. So that greatly simplifies the end management. So we have an operator in CNSA and its controllers, and that's what manages your Spectrum Scale cluster once you deploy it. It's not like an operator like sitting down in a chair being that admin that we're used to. It's just a control loop that takes care of everything for you. We support architectures X, P, and Z. And the cool thing is if you are a current license holder of our data access or data management editions of Spectrum Scale, you have access to container native storage access free of charge. So go try it out and see how you like it. And of course, give us all the feedback because we love that. Here's our containerization journey. So we started in 2018 with IBM Storage Enabler for Containers. So this was the precursor for Container Storage Interface. That was what allowed us to Spectrum Scale to use persistent volumes for running applications in Kubernetes and OpenShift clusters. In 2019, we released Container Storage Interface, and it simplified a lot of that storage enabler for containers had already presented with respect to persistent volumes. In 2020, we introduced the first release of container native Spectrum Scale. And this is introducing the client-only version of Spectrum Scale with remote mount to a storage cluster that's on-prem. So just to be clear on this little thing here, CSI alone with a classic Spectrum Scale deployment can be used in Kubernetes. Container native Spectrum Scale is used in OpenShift clusters only. We support OpenShift, and we run on CoreOS nodes. So today and the futures, we're looking at enhancing our clients. We're looking at trying to incorporate storage on the worker nodes itself with Erasure Code Addition on the OpenShift clusters, AFM Cache, AFM S3, and also looking at enhancing the protocols that are offered by Spectrum Scale today. S3, NFS, Samba, HDFS. We're also looking at the disaster recovery functionality of AFM and extending some more container use cases. CSI 2.2.0 also released not too long ago, and that provides a snapshot capability. And Spectrum Protect Plus is leveraging that today using CSI snapshots for backup and restore solution. Here's just kind of a brief picture of what our Spectrum Scale container native storage access cluster looks like. So to the left, you have CNSA, and we also, we work in tandem with CSI, so it's one whole package. And we run on an OpenShift cluster. What you see here are 3 worker nodes running CoreOS and your Spectrum Scale client cluster or compute cluster. Harold will cover this in much detail with the nomenclature of everything that we call it. But for every eligible worker node, you get one Spectrum Scale pod, which is your Spectrum Scale node in the cluster. We have the core pods, we have 2 perfmon pods or the PM collector, and then also 1 GUI pod. We also have the CSI pods running, and that's how the applications running on your OpenShift cluster access your Spectrum Scale cluster. We have a cross-cluster mount to our backend classic Spectrum Scale storage cluster, and that's where your backend storage is. So once you're remotely mounted from your client cluster, your CNSA cluster to your storage cluster, that's where your backend data will reside. Here is our CNSA and CSI compatibility matrix. With our release of 5.1.1.1, we support CSI 2.2.0. That came out back in April, but that's what we're pairing with CNSA's offering today. Again, we support X, P, and Z. Our scale level is that 5.1.1 PTF1 release level, and our OpenShift supported levels are OpenShift 4.6 and OpenShift 4.7. We're not yet supported on Kubernetes, Red Hat, nor Ubuntu. If you want to check out our section 17 of our Spectrum Scale FAQ, there's the interop tables in more detail. We like to stay current, especially with OpenShift, just so we can get those added securities, all that comes with staying current. So that's why you'll see that there is an accelerated pace at which we kind of keep in step, which may differ from Spectrum Scale today. Now, how does my operator simplify things? So operator ensures the state via its controllers, and their control loops are otherwise known as reconcile loops. Each controller has a declarative state, and that's the desired state it aims to achieve. This is kind of a different mantra, right? In Spectrum Scale today, you have an admin who kind of fine-tunes every single little thing. It may be more procedural. And you can kind of pivot like, oh, if something happened here, what do I do with this? So you kind of go with the flow on that. With an operator, you have this reconcile loop, this control loop, and that one state that you want to get to. So until it gets to that state, what it'll do is it'll stop at the top of a circle and go. And if it hits something along the way, it'll go back to that top of the circle and try to complete that loop to achieve that desired state. So with our 5.1.1 release, we actually have 3 controllers. The first one that, the biggest one here, the scale cluster controller is the one that creates all the resources necessary to deploy your spectrum scale cluster, including the GUI and the PM collector pods. The GUI and the PM collector pods are stateful sets, and the GUI has a replica of one, and the PM collector has a replica of 2. So you'll see 2 PM collector pods, 1 GUI. So that'll create all the pods that you need. The remote mount cluster is what we use to configure that remote file system on the remote storage cluster that we use for our backend storage. So that's this controller's job, is just to establish connection to that storage system, establish the file system that's on the remote system, and then be able to mount it and be able to use it. And we use the GUI API for this to complete that connection. The call home controller is responsible for configuring call home. It monitors the CNSA cluster and sends alerts and events to IBM support, just like it does for classic Spectrum Scale today. It's just a different controller, so it just always monitors. All these things do. The controllers always have that reconcile loop that just want to make sure that that state is good. And that's how it simplifies it for the end user, because you don't have someone that's always having to go back, but instead relying on the controllers to keep that state copacetic. There's going to be a future talk on call home functionality, so stay tuned for that. One thing I do want to reflect on with operators, though, is I know that with classic Spectrum Scale today, people just want to do what they know how to do, right? Go onto that individual node, do a change config, fix it up however they want to. The thing is, the operator lives in that Kubernetes or OpenShift space, so it has its state of the world, and that's how it manages that desired state. If you go and change on anything on Spectrum Scale cluster itself, like you do on a classic Spectrum Scale system today, that's kind of a different brain. So I call it split brain, because you have one state with your Spectrum Scale cluster and one state with your Kubernetes and OpenShift with the operator. So if you try to hand tune something on your worker nodes or your Spectrum Scale cluster outside of the operator's site, so if you're trying to OC exec or trying to do something on the side, that may not work out for the operator. The operator doesn't know anything about that. So what it may do is when it walks that circle, that little control loop again, it may overwrite what you just did. So that's why we really want to lean into the operator, because it automates everything for you instead of, so it's moving away from that hand feeding and hand tuning everything for your individual Spectrum Scale nodes, but allowing the operator to take care of everything uniformly and to be able to have that one universal state. So let's cover what's new in CNSA 5.1.1.1. So we are supporting the upgrade for container native storage access to 5.1.1.1 from 5.1.0.3, our previous release. With CNSA 5.1.1.1, we are also splitting our images into the data access edition and data management editions. And we are also hosted on the IBM Cloud Container Registry. This is the big thing here. In previous releases, you had to install, you had to get your images from Fix Central, put them on your machine, expand those images, load them up into your OpenShift internal registry, and go through that process. Now you'll be able to pull directly from the IBM Cloud Container Registry once you configure up your entitlement API keys, and then you'll be able to pull directly without doing all that extra work. So this is a big, I think, user boon for us this release. So as part of that Fix Central bundle that used to have our Docker archive images and also the YAML manifest for deployment, we also now have a presence in public GitHub. And I'll show you the link to that later, but that's where our YAML manifests are. And that's what you need to deploy our cluster. And so in our IBM documentation, everything will be inline to create your operator or anything that it needs as far as RBAC service accounts, etc. We also have a new must gather image that's specific to gathering the Kubernetes diagnostic logs that we need for our spectrum scale cluster, and also the ability to obtain that GPFS snap from our spectrum scale cluster. Must gather is a technology that OpenShift has today. So if you run into like a failed installation or something with OpenShift, Red Hat, and you want to open a ticket to Red Hat, they will ask you to run an OC80 must gather to get them some diagnostic logs so they can, continue with their debug. This must gather image is following that same kind of suit, except this is specific for your CNSA cluster. So this was another good add for debugability, this release. Just to bring it home with our more notable changes for 5.1.1, if you had previous experience with our previous releases, the first thing I'm going to point at is what happened to the OpenShift internal image registry steps. Like I had mentioned, now that we're hosted by IBM Cloud Container Registry, there's no need for you to configure this internal image registry anymore. So that takes away, 10 to 15 minutes at least to configure that. So don't be alarmed when those steps are gone. You don't need them. The other thing is what happens to all the YAML deployments or the YAML files that you need for deployment. With our first introduction into 5.1.1 and then 5.1.3, you'll see that there was a list of each YAML manifest. So it was a series of OC creates or OC applies, 5 to 10 files. Now with our 5.1.1.1, we've leaned into a technology called Customize, which basically collapses all of those multiple YAML files into a single deployment YAML file. So that's all in line with our IBM documentation, but it also just makes it easier for the end user because you're executing one command instead of the 5 to 7 or 10 YAML commands that we used to have in our previous deployments. The other big thing is, so the scale cluster custom resource, for those who are not familiar, that's what ultimately creates your spectrum scale cluster. And there was an images block in there that defined your core image, your core init image, your GUI image, etc. That's all the operator's job now. So that image block is now gone. So when you don't see it in the custom resource, don't be alarmed because the operator's got you. It's going to, based on the license field where you provide either data management or data access edition, what it will do is grab those respective images from the IBM Cloud Registry and then create your deployment accordingly. So you don't have to do this again. It kind of removes that. We're using image digests, and those can be quite long. So if you fat finger that, if you had the images block, that could be, how come my pie is not coming up? Well, I fat fingered the last character in the digest. You don't have that problem. The operator's got it, so you'll get it every time. Goodbye, Fix Central. And thank you. So it used to have a combined tar file that had our Docker archive images and also our deployment YAMLs and also that collect log script. So all that has been revamped. So now if you go to Fix Central, you'll see a redirect to the image registry. And if you click on this README here, it'll give you all the information you need to go get your entitlement key and then redirect you to our IBM documentation so you can continue with your installation or your upgrade of your CNSA cluster. So these are the steps that are pretty much verbatim from that README. So you log into the IBM Container Software Library with your IBM ID, and password that's associated with the entitled software. You use your IBM ID to log into IBM. However, when you're creating your credentials for your deployment to access ICR-IO, you're going to be using the user CP. So you log in, you get the entitlement key, and there's a nice little copy button that you'll click and you'll get that. And we'll show that in the demo here in a second. Save that key because you're going to use that to configure your CNSA deployment. And of course, after you receive the entitlement key, then you're going to proceed on to the installation. And this is our link to the official IBM documentation for CNSA. So just to give a shout out to our public CNSA GitHub repository, you don't really need to know about this, but it is there. So we're at github.com, IBM Spectrum Scale Container Native. It has our manifest files that you need to deploy CNSA and also the machine config operator files needed to configure OpenShift. These were previously packaged with that fixed central tar bundle, but now it's stored here. Again, you don't need to know about this repo, but in case you're curious or you want to play with Customize for the first time, it's there. This is just an example inline GitHub link. This particular link here, this OC create, has the raw GitHub address, which that IBM Spectrum Scale operator YAML gets deployed into the IBM Spectrum Scale namespace. That YAML file, it's not just the operator, it's the RBAC, it's the service accounts, it's that condensing of all those files, so it'll make that operator's deployment successful, along with setup, everything that's required for that scale cluster custom resource that ultimately creates your Spectrum Scale cluster. So that's all in one command now, and hosted at our public GitHub. And that's what this looks like. Just a pretty picture. So now we'll get on to the exciting part. Everyone loves a demo. I hope this is going to work. But what I'd like to show you today is how do we get our entitlement key from my IBM for the IBM Cloud Container Registry. I'm going to update the global pull secret on my provisioned cluster. I'm going to create a CA cert. I'm going to create the storage cluster GUI secret. I'm going to deploy the operator, and then I'm also going to deploy CNSA. So hopefully we're going to make it through this and it'll be super quick. The one thing that I might just have to move on to, Harold, is when we deploy the CNSA cluster, I think I've been having some issues on my local system. To pull the image takes some time. I'm not really sure why, but I did want to show you this today. I know the operator deploys right away, and that may just be enough to show you how it's pulling the image from CP ICR IO. So let's try this out. All right. So here I have my OpenShift cluster, just to give you an insight. It's running 4.7.13, Kubernetes level 120. And to look at my nodes, it is a 3 master, 3 worker configuration. And I've already created my project, so you'll see that I'm in the IBM Spectrum Scale namespace project. So that's where I'm going to build everything. I've already applied the OpenShift machine configurations that I needed because that takes about 20 to 30 minutes on this particular cluster, and we didn't want to see that. That wasn't what was important for this particular demo. Let me see if I have my link to our official IBM documentation. And since I blew by everything just till we get to this point, we're going to access the IBM Cloud Container Registry. And here, we'll click here to the software library. I'm going to open it in a new tab so I can get back quickly. And here you'll log in with your IBM ID. And this will load the container software library. And then here's my entitlement key. And there's that nice little copy key link that I have here. So what I'm going to do is I'm going to put it off to the side here, as the documentation has told me, just to kind of keep for safekeeping. So I'm going to say this is my entitlement key from my IBM. we're going to use that here in the next step. So we logged in, we clicked on the Get Entitlement Key, we copied the key, and now we're saving the key. Well, secure. I'm trying to show you guys what to do, so pretend this is secure for a second. The next thing we're going to do is create that global pull secret so we can access our container registry. So we're going to walk through these steps together. So let's go here and do an echo -n. Remember our user ID, even though we logged in with our IBM ID, the user ID to access your container images on IBM Cloud Container Registry is CP. So CP : and then copy that entitlement key here, because we're going to create that base 64 string that we need for, oops, don't do that. Finish the command, base 64. I think it's -W0. Yep. There we go. So we'll copy this off to the side. And I will call this my base 64 string. All right. And now we're going to create an authority block that's going to be the information that we need to access the CP ICR-IO. So basically our IBM Cloud Container Registry. So I'm going to take this here and copy it. I'm going to use VS Code because I like that it gives me squiggles when things are wrong or shows me like this. So for auth, it wants our base 64 encoded string. So we're just going to grab that thing here because we just did it. If you're copy pasting, remember to keep those quotes and that comma. We don't want to mangle the JSON. Our CP ICR-IO username is CP. And our password is the entitlement key that we got from my IBM. So again, get rid of this, replace it with your generated key. And then this is basically making that authority.json. So what I'm going to do is copy this, go back to my system, use good old VI to create authority.json and put the contents in there. That all looks beautiful to me. So we're going to save it and then go on to the next step. Using this authority JSON that we just created, we're going to try to modify our Docker config JSON. So what we're going to do is it's going to pull what's in the Docker configuration that's in our current pull secret so we can enhance it. Note that you're going to want JQ, which is a fabulous tool for editing JSON. So we'll need at least version 1.5 for that. So I'm going to copy this command straight from the IBM documentation to get that pull secret information and create this temp config JSON file. So now I think we do a cat is what, yes, just to show what's currently in here. All right, so you'll see that it added what we just created from that authority block for CP ICR-IO. So now that we know that the temp JSON is kosher, we're going to go ahead and just update that pull secret in step 4. It's going to use the contents of that temp config that we just verified had our credentials, and it updated that pull secret. So in order to verify that our stuff is now there, we're going to issue this command just for extra warm fuzzies, and we see our authority block is there. If you're running OpenShift 4.6, this is going to give you a rolling update. So you might want to plan that accordingly. Since I'm running OpenShift 4.7, they don't reboot the nodes. Again, another reason to always try to stay in line with OpenShift, the latest and greatest, because you kind of get these cool things where it's not cycling through your whole cluster trying to manage it. And then step 6 is just cleaning our campground, getting rid of those files that we made. All right, so we've established our global pull secret. Now we're just going to walk through the next couple steps so we can get to our deployment. The next step is creating that certificate authority for our storage cluster GUI. What I'm going to do is take option 1 and do a self-signed, and I already copied it here since I have my storage cluster here. Doing a self-signed certificate. for my storage cluster. So we're going to create that config map. It's already created because I didn't clean up my cluster yesterday, but that's okay because we know it's there. And then also creating the GUI credentials for the storage cluster. The storage cluster has already been created and already has the container operator user that you need. So I can rely on that. And it also has just the defaults here just for our demo purposes. So creating the secret, and again, I think this already exists, but just so I can prove to you guys that, yeah, I didn't clean up my cluster and it exists, we'll create that secret for the storage cluster. And again, cool, it already exists. Now we can go down to create our operator. I'm going to lean into the power of the operator and just let it do the node selectors and labels. If you want to, you can go ahead and try to configure your node designations, but the operator's already got you. It's going to configure what you need for quorum, your collectors, all that kind of good stuff. So next I'll go into operator deployment preparations. If you wanted to, I'm not going to. You can download the scale profile and here's the link to it in our public GitHub. You'll download this YAML and edit it to what you like. It's very imperative you create this before your CNSA cluster because that's when we do the cluster creation using this profile. If you don't want to do this and just go with the default configurations, that's fine. And that's exactly what I'm going to do. But if you wanted to tweak it, do it before the cluster create. We currently have support for editing your cluster once it's been deployed. The next is the scale cluster custom resource, which again is what actually is going to create your CNSA cluster. And here is the curl command. I am, for demo purposes, I'm going to move that. So I'll do the curl. What this will do is just pull down that scale cluster custom resource here. So what you'll see is this guy here. So this is our default CR that you just downloaded. So what you'll want to do is go and edit what you'd like. You'll notice that with license field, the default is false and the default license is data access. What you'll want to do is change this to true for your license and put in the edition that you have the licensing for. And that'll tell the operator which images to pull based on what edition you have targeted. Here is your call home controller block. I'll go through this real quick and then I'll show you what I have. Where you put all your input for your company name, your company email, and a proxy server if you have one. The file systems is how we configure the file system that is on the storage cluster here locally on CNSA. So here we'll be creating from the default is FS1, but it's trying to show you that the storage cluster maps to the storage cluster 1. Your mount point on CNSA is mount FS1. This is a CoreOS thing to use MNT, so you must have that there. Otherwise, it's probably just not going to work. Here's your remote cluster, and there's that storage cluster 1, which is the reference to this. So basically, you're saying my file system is file system 1, which lives on wherever this name storage cluster 1 is referenced. So it's going to reference this guy down here, this remote cluster block. Here's the CA cert secret that we created. You'll put your GUI host here, the secret that contains your GUI credentials for your storage cluster, and then insecure skip verify. That's what says I want to use my CA cert to make sure that this connection is good. Host aliases, that's optional, but I would just use it. So what I put here, and I'm going to transition over to mine. So I'll copy. All right. So here is my actual CR that we're going to use. You'll see that my license is true. My data management edition is what I want to deploy. I have call home enabled. All with my stuff, and I have it as test because I don't want any red flags. I just want to test it. I'm configuring a file system 2 from my storage cluster 1, which is the GUI host is gsanjay. Here's the secret name, the CR cert, and my contact nodes. So those familiar with Scale will know that contact nodes are just other nodes in your cluster where you'd be able to actually get to your GUI host. So we're just trying to guarantee that connection. So host aliases, it's optional, but I would really lean into it. I don't think I've ever seen one work without it, but I think that's my dev environment. So I'm not sure with external customer environments, but basically what you have for your GUI host and what you have for your contact nodes, what I like to do is just make sure I put whatever those IPs and those host names in here too, just to give that extra guarantee that you're going to actually get to your storage cluster. So that's what I have here. So that was this step, editing your Scale cluster custom resource. So next we'll go to creating the CNSA cluster. Step 1, so we're going to deploy the operator using this single nifty command, which is pulling that file that has that concatenated giant YAML file that has all the RBAC that we need, the custom resource definition for our Scale cluster custom resource, and ultimately the operator. And we're going to deploy it in our namespace, IBM Spectrum Scale namespace, which is the project we're in. OpenShift calls them projects, Kubernetes calls them namespace. It's the same thing. So there we go. We created all these things, the custom resource definition, the service accounts, the roles, cluster role, the role bindings, the cluster role binding, and ultimately the deployment for the operator. So now if we do an OC get pods, we should see the operator pod, and it's already running. So let's go ahead and inspect that. And we're going to do a describe on the pod. Yeah, if I could type it. All right, so what you're seeing here is it's pulling the image from ICR CP Open. So CP Open is the open part of our image registry. So that's where our operator lives. We'll eventually migrate over to being an OLM or anything. And that's what we want, is just that openness for our operator. So you'll see that it successfully pulled it from the container image registry and brought it on here. And that's why we realize the operator is up. The next thing we'll do is step 2 of this and create our Spectrum Scale cluster. We'll do a get pods to see what happens. All right, so the operator has seen that Scale cluster custom resource has existed. So it deployed the daemon set that creates your Spectrum Scale core pods, which comprise and make up your Spectrum Scale CNSA cluster. It also created the GUI and the PM collector pods. It's waiting, but there will be 2 of these once it's realized. What it's doing right now is it's thinking about pulling stuff. So that's where I think I'm going to transition back and talk about futures, and we can check back on this in a little bit. Actually, this is good right here. I like looking at this with people. So we're in Kubernetes OpenShift. There's status and events, and people just don't like seeing failures. And here's what you'll see in the describe, right? It says it failed the volume mount, it failed this, my secret's not there. So let's review back with the operator and the control loops. There's a circle that it wants to complete, that control loop. It wants to complete that reconcile loop. So there's a lot of names for it, but basically it's a loop to get to that one ultimate state. At this point, it's trying to go to, I don't know, 3 o'clock, and it says, I don't know where this is, and I don't know where this is, I failed. So, and you'll see that it's doing it over and over and over and over again. So it fails, it goes back to the top of the loop, it goes back again, tries to find that secret, it's not working, it's going back. That's okay, this will resolve. If it doesn't resolve, there's a problem. But this is transient event stuff that we see in Kubernetes. It's, you know, it's just showing you the state of things right now. There it is now, see? It's been 104 seconds and it's tried 8 times. It's just trying to complete that loop. So that's what the operator is trying to do for you. So once this resolves, it'll move on and we'll see the events. So We'll just do another get pods to show that it's still working on things. And it's been 2 minutes since we deployed the scale cluster custom resource. So we'll come back to this, but in the meantime, let's go back to the presentation. All right, so looking forward, we're looking at containerization beyond what we have now for the client. With our first release in December of 2020 and the most recent releases, it's just the client version of Spectrum Scale, which remote mounts to the storage backend cluster via the remote mount capability through Spectrum Scale and also through CSI. Common misnomer that I think CNSA has is, hey, you put scale in a container. True. But that doesn't mean that we have the full functionality that's realized in Spectrum Scale today. But we're working on it. And that's why I really wanted to highlight what we're going to look at going forward. But, you know, we're a file system, so that's kind of different from what like typical applications running on Kubernetes are. You know, Kubernetes applications and pods are stateless. We're very stateful being a file system, you know? So we're working on trying to figure out, how do we live in Kubernetes space? We need to think declaratively and try to reframe how we process things in Spectrum Scale today. So that's kind of what we're looking at and unraveling along the way. So we're trying to make that prioritized list of functionality and everything. So we are looking at containerizing local storage using AFM and ECE. So that's storage that'll be realized in your OpenShift cluster instead of using the remote mount storage cluster offsite. We're looking at containerization of encryption, containerization of the existing functionality we have today in Spectrum Scale encryption, the multiple file system support, the multiple remote cluster support, and also supporting protocols, S3, Samba, NFS, HDFS. We're in OpenShift right now. We're not in vanilla Kubernetes yet. We're going to work on that. We're also going to look at supporting public clouds, IBM Cloud, AWS, Google, Azure, and also support for edge computing. We realize that the user experience for CNSA has a lot of improvement that needs to be made. We feel like that we delivered a little bit more with that in our latest GA of 5.1.1 with having our container images hosted by a container registry. So that's one step. So that got rid of something. But we're also looking at the integrated deployment of CNSA and CSI. We realize that that looks like a very disjointed installation because it's a two-step process. So we're looking to integrate that, and how do we make the operator encompass both of those things? We're also looking at down the line entering the operator lifecycle manager, which also simplifies the deployment of the CNSA operator, because then you'd be able to go to your OpenShift cluster GUI and be able to pull it from Operator Hub, no problem. We also realize that rolling upgrade is not there yet. So it's a disruptive upgrade when you want to upgrade between CNSA levels, but we're looking at this enhancement in a future release, near future release. We're trying to get that in the end of 2021 here. But really, tell us what you like to see, because there are so many neat functions, everything that you guys know and love with Spectrum Scale that are not yet realized in CNSA. And we need that prioritized list. So tell us what you want, tell us what you really, really want, and let us know. I think there's an opportunity to do that later. So let's just pop back real quick. Yay, everything is running. So you'll see 2 minutes in, everything was still configuring. Uh-oh. GUI, why you got to do this to me on the live demo? But let's just look at one of our pods quickly. So what we'll see here is, see how it had those, I was unable to find my keys or whatever. It completed that loop and it got past it, so it moved on. It was able to pull the image that we needed for the initialization containers from CPIO or CPICRIO, so from our IBM Cloud Container Registry. We ran through that first initialization container. We pulled the, or let's see, it's already present because I ran this last night. It ran the configuration container, which is the config container that establishes and creates your initial spectrum scale cluster and then starts adding nodes to it. And then it ultimately runs the spectrum scale daemon controller image, which is the realized GPFS container, which is now running. I'm guessing GUI is suffering from a case of the Docker pull limit. So let's just take a look at that real quick. Yeah. So I work on, my cluster is on IBM Cloud Provisioning, and there's anonymous pulls. So we run into this all the time, and your customers might do so as well. There's Docker.io has a pull rate limit, and our GUI pod uses PostgreSQL. So what you might want to do is configure a Docker login, so you have that support with your cluster. What I'll do now is a workaround where it's actually, because we've hit this so many times, it's in our troubleshooting under known issues. And I believe I already have the secret and this all set up. So basically, I'm not going to create the secret because my secret already runs. So if I say OC gets secret, let's see, Docker. It exists. I created that. We'll just do this for fun. We'll link up. So this is the IBM Spectrum Scale GUI service account to be able to use the credentials in this Docker secret for pull. So we'll do that. And then we'll have to delete the GUI pod. What that will do is delete it. And once that pod comes up again, the service account for GUI will be linked to my credentials for Docker, and we'll be able to pull the image from Docker because I haven't pulled more than, I don't know what the Docker limit is for daily, but I'm sure this is my first pull for today, so we should be okay. You'll see that the GUI pod is terminating from that deletion. Take some time. Well, I don't want to take up too much time. So good. Cool. So now you see that that pod's gone. It's creating the new GUI pod. Okay, so it's already up and running, or it's almost up and running. Liberty is the last container, and that will take some time. So what I'll just show you is the describe of the pod to show that we've moved past that Docker pull. We should be able to see that we were successful in pulling. Yes. It was saying it's already present. So it was able to reference this Docker.io image for Postgres, and that's why it was able to be successful. Liberty is coming up, and actually I'll show you that, I'll prove to you that it's actually Liberty that's waiting to come up, because in the pod describe, there's our container Liberty. It's not ready yet. So that's the last one that's waiting to come up. And it will eventually, but I just really, for the purpose of this demo, I just wanted to show you how we were able to create our CNSA cluster using the IBM Cloud Container Registry, creating that global pull secret, and just being able to pull that without creating that OpenShift internal registry that we previously had. So with that, I think Harold will show you better things and from the field, firsthand experience, and I will pass it over to Harold.
Thank you so much, Laura. Great stuff. And I'm going to talk a bit about some first-hand experiences I had with various installations. In fact, on both x86 platforms as well as IBM mainframe platforms. So these are the predominant platforms I'm dealing with here in our EMEA kind of client base. And yeah, as I've got the EMEA focus, this is what I used to be dealing with. So I'm going to attack this from a couple of perspectives. So first, let's look at what to watch out for when you plan and when you kind of consider the architecture for CNSA. Then I will go into some hurdles with regards to installation. One of those you've just seen, I mean, this pull limit issue also in there. Then some items to be aware of during operation. And then finally, some pointers on how to troubleshoot. And also here, Laura has nicely demonstrated you some ways to troubleshoot, and I'm just going to wrap it up then. So let's dig into the architecture planning stuff. First of all, this is the kind of overwhelming overall picture, kind of zoomed in here. And you might recognize that in some parts of our documentation, we call the CNSA cluster on the left-hand side. So all the stuff that is running on top of OpenShift, the compute cluster from a spectrum scale perspective, and on the right-hand side, which could be the storage cluster based on physical machines, virtual machines, or ESS as the storage cluster. But I mean, interchangeably, you can also have this labeled as the accessing or the local cluster. I mean, local from the perspective of the application, which is OpenShift and the workloads on top of it. And then obviously on the right-hand side, for example, in the CSI documentation, we have the notion of the owning cluster as representation of the storage cluster. Or and in some other places, it might be referred as remote cluster. So all these kind of labelings are interchangeable in the way that I showed you. So hopefully this helps you in case you're struggling at some point in the planning or installation process. So when you kind of thinking about how you roll this out, you get high availability on your local cluster, on your OpenShift cluster by means of OpenShift as the container environment. And also going back to a question in the chat, I mean, what happens when a scale core port dies or a node running a scale core port dies? This is very similar to when a client node in the Spectrum Scale cluster dies, with the difference that the application will then be moved to another node, and the remaining scale core ports will kind of just serve this. So there's no need to kind of move a scale core port over to the other node. So this is a kind of deployment in Kubernetes that ensures that every single machine holds at least one scale core port. And if you then look further, like how a resilient infrastructure that is crossing sites might look at, there are at least two different approaches. One approach is in case you conceptually have designed your applications, or you've got kind of out-of-the-shelf applications that do replication themselves, like some databases do, some message queue persistent applications do, some other applications do. Then obviously you can have multiple storage backends behind it, like the Spectrum Scale clusters that are not interconnected. So in this particular case, your application kind of traffic is replicating the data, and then the backend data is stored on your storage entities in each of the sites. In case that is not the case, then you might look at a resilience architecture where your storage is actually replicating the data, and then your applications need to be switched in a kind of active passive scenario or moved over to the surviving site. So, as you know, from a spectrum scale perspective, we have these essentially two replication concepts, which are the stretch cluster in case the distance is not too far among these two sites, or you could potentially use AFM, active file management, to do the replication behind of that. And then when you look at the application side of the view, there's again, two different notions that could be in place. Some applications actually are aware that the underlying storage might be stretched across the clusters, like you have a shared file system that's available on both ends of the sites, on both sides. And so potentially the application is handling the failover by doing some locking on one side, and then if the site goes down, the other side might be able to take over the lock on the data. If that is not the case, and you do have applications that need to be manually moved, then you can use the spectrum scale CSI static provisioning to recreate the access on a Kubernetes level to the applications, and then scale up the application on the surviving side. One of the previous spectrum scale talks explaining container native, I had a more detailed description on that, so you might have a look there. In the future, we are looking together with Red Hat on automating these concepts. So to actually provide an automatism to also move over stateful applications to the other side in conjunction with the failover of the storage, or the presence of the storage on the surviving side. If you're interested, watch out for a project called Raymond DR. That's an open source project that is kind of providing some plumbing for this failover for OpenShift container workloads. Another thing to care about when planning is the versions, and I think Laura already has shown you the whole kind of history of versions here. This is a very specific kind of thing to care about when you're also dealing or wanting to have snapshot integration with OpenShift, like in the more recent versions, starting with 5.103 and CSI 2.2. So if you have upgraded your Spectrum scale cluster to 5.1.1, which is the prereq for having snapshots working on the OpenShift side, then you also need to take care to change this release level. Otherwise, the compute cluster, the CNSA cluster on the left-hand side, and the CSI driver might not be able to recognize that the version is recent enough to perform the necessary operations for cloning volumes from snapshots. Then if you consider to put in firewalls between your OpenShift compute cluster and the storage cluster, the Spectrum scale cluster, you need to really take care on having the appropriate ports open. It's like when you take care about firewalls in between cluster nodes on your storage cluster. As you can see here, these are the same ports, but as we are having this kind of remote cluster mount, you need really to take care about consistency. So, for example, the ephemeral ports that you open on your that you choose on your storage cluster, the same port range needs to be selected on your CNSA cluster, and the ports also need to be on the same range. Otherwise, you might see things working, but only to some extent. For example, you might get timeouts on the CNSA cluster for a particular subset of commands. So be sure that you pick the ephemeral ports on the same range on both ends of the story. Then there used to be a quite, I would call it exotic use case where one of my clients had a firewall in between the nodes of the OpenShift cluster. This used to be a Red Hat OpenStack platform-based installation. And in that particular case, you also need to take care about a couple of more ports, like the ports used inter-cluster, so within the Spectrum Scale client cluster. And then you obviously need to open up all the given ports like shown on the upper part here. And there's one very special additional port, and it's port 1, 2, 3, 4, 5. Quite a funny selection. This port is being used for pod-to-pod communication across the container, the containers that Spectrum Scale uses. So these ports also need to be opened across the nodes. Some of the clients also use the notion of so-called infra nodes. So infra nodes are essentially worker nodes, but they get a special node label. So they are labeled as infra rather than worker. I've even seen one case at a client where the node was labeled infra and worker at the same time, but usually the nodes are labeled infra. Recently, a question came up if it's allowed to deploy Spectrum Scale on these nodes, because Red Hat actually restricts the licensing for these nodes to only run a specific subset of services on top of that. And if you dig deeper into the documentation here, you will find that it is indeed allowed to run storage infrastructure services and also network infrastructure services on these kind of nodes. But if you want to deploy a CNSA on these nodes, you need to modify the predefined node labels and node selectors in your scale cluster custom resource a bit. And like I described over here, that's one potential solution for that. So just label the nodes with the node label scale here, like shown. And then you can put in a node selector in the custom resource so that the operator, the Spectrum Scale operator, essentially picks all of these nodes, including the infra nodes for deployment of CNSA. And then the next question you might ask, what about control plane nodes? I mean, the master nodes within OpenShift. Can we also deploy Spectrum Scale CNSA on top of it? The answer is not yet. So currently, we exempt the master nodes from Spectrum Scale deployment. But I mean, in the future, and this might also be relevant for edge kind of deployments, also with the upcoming Spectrum Fusion, you might think about a very stripped down OpenShift deployment where we just got 3 nodes with these combined master worker kind of labeling. So we call these stacked master worker nodes. And we are looking to support this particular scenario in the future, but not as of today. Then we already talked a bit about the image registry, and Laura has just showed you how this Docker.io pull limit looks like. I mean, this is most likely going back to we as IBM living in this 9.x network, and a lot of people within IBM pulling a lot of images from Docker.io. So it is likely that you are not running into this issue. But it's one of the downsides of just using public registry. And as Laura said, with 5111, we are now able, if you like to do so, to pull everything from external registries. So eliminating the need for a local registry if you want to do so. On the other hand, many of the clients, and we do have examples here in the Q&A, are using private registry for good reasons. I mean, they are using, for example, air-gapped installations, so no connection to the internet from an OpenShift cluster perspective. And obviously, then we need to be sure that all the required containers are accessible. And I think the documentation team has done a great job with the latest version in assembling all the required information for air-gapped installation. So have a look at the 5111 documentation. There's a very nice kind of walkthrough recipe that allows you to kind of move over the images into your internal registry. And calling it internal registry, there's still two flavors. I mean, internal registry from an OpenShift perspective is the registry running internally in the OpenShift cluster. And you can do that two ways. One way is to consume external storage, like preferably object storage according to Red Hat documentation, but you could, at least for test installations, also use NFS or even CSI storage. That's sometimes a bit of chicken and egg problem, but in case your CSI is installable without a on-prem registry, you can even put your internal registry built into the OpenShift cluster on top of a CSI driver. I would just kind of put out a word of caution to avoid this potential way to use the so-called empty dir construct for the internal registry, because that at the end is just using some storage from a given core worker node to build the registry. This is probably the fastest, most quick and dirty solution to bring up this internal registry. But we've seen the case that a client has done that and then just forget about it because the registry was working, and then later on doing HA tests and recognizing that this registry is really not HA capable. So please don't use it unless you can avoid it. Some words about DNS, and this is going back to Laura's comment about the host aliases. In fact, when you have perfect DNS resolution, I mean forward and backward resolution, also for all the storage cluster nodes, you can indeed skip this host aliases section. But in case you don't, like in this IBM internal cloud example that Laura has showed to you, you might want to leverage this host aliases kind of local DNS resolution. This is similar to people on the scale side using the host file as a kind of last resort in case DNS fails. So you can do this, but if you have proper DNS resolution guaranteed all the time, you can just skip that. And also, it's worth to note that it's highly recommended to get consistency of what you see with this OC get nodes command. So node names on the left-hand side, these also should be properly resolvable DNS entries that point to the given OpenShift nodes. Otherwise, your CSI driver needs to be configured with a similar mapping scheme to allow the identification of these nodes in a proper manner. Okay, let's switch gears and look at the installation. I again have the firewalls section because I told you that this port range needs to be consistent in case you have a firewall in between. So the ephemeral port range needs to be consistent on the storage cluster as well as on the compute cluster. And the way you can achieve it is by this scale profile YAML that you need to deploy before you actually start the cluster bring up for CNSA. And I've pointed out the location where you can put this command over here, or this option. Then, I mean, this is something people are currently struggling with, including myself. These different custom resources. I've collected some pointers that hopefully help you to better understand how things tie together. So for the scale cluster custom resource, so when you install CNSA, you have this tie between this storage cluster kind of variable, and then in the specification of your remote storage cluster, this same given name, and this is just a name that you can choose yourself. So this can be the cluster name designation, but it can also be any kind of free-form text. It just needs to be consistent, as pointed out here in the center of the drawing. On the CSI side of things, on the right-hand side, there is the identification of the clusters with the cluster ID. And we have got these kind of two different records in this custom resource. The first piece, the box on the top, is for the accessing cluster or the local cluster or the compute cluster, where you put in the ID of the remote cluster. So this is the kind of link to the lower section where you got the cluster ID of the owning and storage cluster and the relevant secrets, for example, to access the GUI on the Spectrum Scale storage cluster. And then finally, when you decide to create a storage class, especially a storage class for independent and dependent file sets, you also specify a cluster ID, and you might want to ask which one should I use, and the answer is you also use the cluster ID of your storage cluster over there. So yeah, these are still quite a bit complicated YAMLs, and a colleague of mine over here in Germany has worked on providing a Helm chart that puts all these different configurations for CSI and CNSA into a single kind of deployment with a single configuration. So you might have a look at this GitHub repo. It is currently just available for the previous versions up to 5.103, but Gera is also working on bringing this to the most recent version, 5.111. Another word of caution regarding file system naming. So if you named your file system like in this example over here with an underscore, so scale underscore data, you might run into issues on the OpenShift side of the story because the CNSA file system name needs to be complying to this DNS label name standard over there. So you can circumvent that by just naming your file system on the CNSA side different than the one on the storage cluster. So in my example over here, I named the file system on the CNSA cluster FS1, while the originating file system is still called scale data. Now let's have a look at the operation part of things. It is good practice to avoid some namespaces on Kubernetes and OpenShift. So the default namespace, we've seen some strange behaviors. That is probably not the namespace to deploy applications to. Similar for the OpenShift namespaces, this should be reserved for OpenShift control plane functionalities. the OpenShift namespaces, as well as those of the CNSA and Spectrum Scale CSI driver, obviously also might get elevated rights from a role-based access control perspective. So it's anyway not good practice to deploy any workload to it. Sometimes, I mean, when you bring up a cluster and want to do some quick tests, it is intriguing to just use the namespace where you left, like the CSI namespace. But if you remember the session over here, please go ahead and create a new namespace for your workload and use that one. This might prevent you in getting some trouble. Also, when deploying workloads, it is handy to define a default storage class. For example, when you go to the developer perspective in OpenShift and you want to leverage some of the nice templates, for example, for MariaDB or other example workloads, most of them do not allow you to put in a storage class for your persistent storage piece of the application. Instead, they just look out for a default storage class and just provision what's available there. So in my case, I put in the independent file set storage class for Spectrum Scale as the default one by kind of editing the annotation for the storage class in the OpenShift GUI and putting in this storage class Kubernetes IO is default class and value true. And then the subsequent deployments that do not specify a storage class will automatically schedule storage from the given storage class. Another gotcha is very small TVs. I've seen some deployments, some workloads. One of the examples is also our very own Cloud Pak for Data that provision PVs that are very small, like 1 megabyte size. But in my case, I got a file system block size of 4 megabytes, as you can hopefully see on the upper right here. So then it's obvious, hopefully, and worth to note that the provisioning of a 1 megabyte PV attempts to set the quota to 1 megabyte, but obviously, as the file system size, block size is 4 megabyte, the minimum quota can only be 4 megabyte. So under the hoods, you will get a quota of 4 megabyte. It's hopefully not a big issue, but something to remember. So let's switch gears to the final section here, some troubleshooting hints. The first place probably to look at regarding CNSA is the scale cluster custom resource. So navigate to your custom resource definitions, look at instances, and there you hopefully will find the scale cluster custom resource. And this resource will have some conditions that show you high level what's going on with the scale cluster deployment, so the CNSA deployment. If you want to dig deeper, you can look at the logs of the scale operator. There you will see some REST API communication with the REST APIs, the GUIs of the clusters. And it's also worth to note that in cases where the scale core ports even don't come up, it might be worth to look at the so-called init container. So even before the container comes up, you can have a so-called init container spinning up that does some preparations. And we've seen at least one case where there was a misconfiguration on the Spectrum Scale side that just got revealed by this init container. So please also have a look at that in case you run into some trouble. And then for the CSI part of the story here, the CSI operator is actually doing all the kind of reconciliation of state changes here and is running Ansible playbooks. So if you're into Ansible, you might kind of be able to read what's going on there. And then the next place to look is actually the scale CSI pods, which are the real kind of heavy lifting piece of the CSI driver, and especially because the scale CSI pods holds 2 containers, you need to look at the IBM Spectrum Scale CSI container within the pod. But to make you and us the life easier, we also have provided a log data collection for CNSA. We are following this pattern given by Red Hat to use the so-called must gather process, which is new in 5.1.1.1. So it is similar to retrieving logs for OpenShift itself. We are also pulling the necessary logs for CNSA. And for CSI, we just provide a simple script that collects all the necessary data from the pods that we might need during some troubleshooting. With that, I'm concluding, and I ask you to try out to run SpectrumScale CNSA, because we think it's an excellent way to bring your persistent workload to OpenShift with the well-known advantages of SpectrumScale regarding throughput, scalability, and now we also have integrated it very deeply with OpenShift in the way that we just showed you in the past hour. So with that, I'm turning back to the organization team, probably for some Q&A.
Thanks, Harold and Laura. I can see there's been quite a lot of questions in the Q&A, but I think they've all been asked, all the ones that I've seen anyway. I guess if people have got any more questions, if they can post them in the Q&A, and we'll try and get them answered in the next few minutes.
Sounds good. I'm probably turning it over for some additional comments here.
Yeah, so I think Tom was going to just give us a sort of a quick introduction on this slide.
Yeah, hey, this is Tom. Quick advertisement for the RFE process, right? So I'm Tom O'Brien. I'm the product manager for SpectrumScale. I joined the product management team on Scale about 2 months ago. I'll be replacing Carl Zetti, who's retiring actually this week. So prior to this role, I was in product management for other storage products like Spectrum Protect, Storage Insights, Spectrum Control. So I'm kind of familiar with the storage realm over here. And I'm really looking forward to getting to know and work with all of you. And one of the ways we'll be working together is via this request for enhancement process, right? Like Laura mentioned earlier, we really want to hear from you on what you want to see in the product. And the RFE process really gives you that opportunity to collaborate directly with our dev teams and with other users. So you can go in there and follow that link, and you'll be able to search on existing requests for enhancement, comment on them, vote on them, submit your own, and track your requests. So please leverage that RFE community to get your voice heard. So with that, I'll turn it back to you.
Thanks, Tom, and hopefully maybe one day we'll get to see you in person at one of our sort of live user group events in the future.
Yep. Looking forward to it.
Can you put up the next slide, please, Harold? So just to recap at the end, please do go and take a look at the website. You can see all of the talks that we've had in the past. All of the videos are on there, and we'll be posting the video for this talk as well when we get time to update that. It does take us, sort of a week or so to get the videos cut together and put on the website. So they will be posted online afterwards. All of the slides will be posted up as well. So yeah, please go and take a look there. Can I have the next slide, please? So just finally, we'd just like to thank everyone for joining today. And again, I'd like to thank Harold and Laura for speaking today. Laura said it was the first time she'd done a SpectrumScale user group talk, and I think she did a really good job today. So thanks both of you for joining us and doing that. The IBM guys, they'd like us to remind you about the feedback tools you can use, and also just finally again about the user group website on there. So I think I've not seen any more questions come in. So I guess with that, we'll close up the call. Thanks, everyone.